Hello, I hope all of you are fine. I got a lot of requests from my students. They are willing to join good company, and then they requested me to share dummy questions. Now, fortunately, I got an opportunity from a beautiful company. What I will do, for some reasons, I will not disclose the name of the company. Instead of that, I will share the questions and I will try my level best to show you the simplest solution. Now, this is the question number two. The company shared the two questions. One is related to optimization, and the second one is related to data science. So the question number two I will discuss here. Now, if you check this graph, it is, we are considering at the node, at the root node, we are having one warehouse, and the warehouse, have the four stores, and each store has four different style, and each style has different sizes. Now, what you need to do, this question number one, you need to select a suitable time series model, time series analysis model to predict the demand. Okay. Now demand in, the number of units. So this thing is, uh, different approaches you can do, almost 68 different machine learning approach you can use to, to analyze the time series. Now, what is time series is basically this, one column you're having the timestamp, that is the date, time, month, etc. And another column you're having, say, the value for a particular unit, say for the sales or for this, you know, the productions or whatever it could be, or the price. Okay. Now, what I did basically, I tried my level best to develop a simple approach. Now, this way you can check on the top. I have mentioned the store number, style A, size L, and then from the given data, I have shown, I tried to plot, some lines. And these lines, you can check this green color is basically stocking hand. The blue color is basically the sales. And at the same time, I showed the rolling mean and the rolling standard deviation. At the same time, I showed the distribution. This is basically the KDE plot. I use Seaborn. And at the same time, one of my favorite is, ordinary least square. So I used initially the Excel and I showed, okay, if it is the, you know, along y-axis, if I consider the cumulative demand, along x-axis, if I consider the time, so I can expect to get for a 1 year this type of data. And if I find the trend line, this trend line is equation is given, the r square value is almost 0.969, so almost 96.9% variability we can explain with this trend line. But the question is, this what type of simplest approach, because it is a big data problem, so simplest approach is required. So I studied in detail more, and I checked the distributions of each store, each style, and each size correspondingly, and I got this type of distribution. Now, if you check this distribution, this above two, this is little bit skewed. Okay, this is a little bit skewed. It has a long tail here. It is a tail. It has a long tail, and it is not the normal distribution. So if the distribution is not normal, so you cannot use ordinary least square. I hope you will agree with me. And this is the second distribution. It is, you can check, this is the bi-modal Gaussian distribution. And in this case, you will get this large number of modes you will find this type of distributions. Now, why I'm showing you the distribution, I will show you one thing is this is very peculiarity. That is, I searched thoroughly and I got a white noise. Now, what is this white noise? Let me show you. I think I have. Yeah, if you check this distribution here, that is the bi-modal Gaussian distribution. This is nothing but a white noise because I got this corresponding ARIMA order is 0, 0, 0. What is ARIMA? Auto-regressive integrated moving average. So ARIMA 0, 0, 0 means there is no auto-regression part, there's a moving average part. So it is basically a white noise or a random noise, if I'm not wrong. Now, when you are getting this type of question from any company, so you must check the distribution of the data. This is very, very important. So the company asked me, to use uh, any approach, but you have to justify it for what reason you are using it. So I didn't disclose them, but I use a multiple criteria decision analysis, and I considered the three criteria. That is, one is the simplicity, number two is the accuracy, and number third is the computational time and memory use. So when you're using a particular algorithm, you must think about how much time it is taking, how much memory it is consuming, okay? And at the same time, we are a little bit obsessed with this accuracy. So I showed the accuracy. So three different approaches I use. Number one is the ordinary least square. And at the same time, I justified where I'm wrong, because ordinary least square means when you are using this distribution should be normal. And at the same time, you have to consider that is all the error terms are independent to each other. So the next one I use is SARIMA, seasonal ARIMA, so that I could find out, the seasonality, if any. Now in this case, you can check now this type of orders I got for each product. I plot the original data and at the same time this ARIMA. And what I did, I showed the distribution. And one of my favorite is correlagram, that is this uh, autoregression, autocorrelation coefficient, SCF, and the partial autocorrelation coefficient, PSCF. Now, these are the distribution. At the same time, I showed the decompositions, means additive decompositions I used. Why you're supposed to use the additive decomposition? As because in case of this additive decompositions, you have to differentiate, or you have to decompose the trend, then seasonality, and the residual, and the cyclic behavior, if you find, if any. So I showed it, and finally, it's the time for the machine learning algorithm. So the question was, what type of features you're looking for, and you have to justify for what type of features you must select when you are using a particular algorithm. Now, as I told you, this time series algorithm. So one of my favorite is XGBoost, extreme gradient boosting. Now, XGBoost, I told repeatedly, it is a non-parametric approach. It is a non-parametric approach, just like a decision tree. Means you will get a feature space, then you divide it, and for each local region, you have to fit a function properly. Now, why I'm selecting this XGBoost or the extreme gradient boosting, it's not because of this popularity in Kaggle, it's because XGBoost is based on the uh, the residuals. And what is the residuals? Now, residuals is, you can consider it as an error, the difference between the actual value and the predicted value. At the same time, XGBoost, it uses parallel learning, and at the same time, this sparsity aware split findings, cache aware access, out of code computations, and overfitting. Because when we are considering any supervised learning approach, in the supervised learning approach, you have to be very, very careful about one thing, that is, what type of objective function it is using. In extreme gradient boosting is basically this, it is in the family of additive boosting tree. In the additive boosting tree, what is this concept? The concept is, you have to convert a weak learner to a strong learner. So in this extreme gradient boostings, it is using this objective function, that is this loss L theta and the omega theta. What is the L theta? That is the loss function. And the omega theta, it is for the regularizations. Now regularization we are doing for the overfitting, and the regularizations means both the L1 and L2 regularizations you can use. Now this is when you are attending any interview. There is first thing is what type of speciality you are giving, because any persons can do it. Now features based means in this time series what you have to do. See, you have the timestamp column. The timestamp column you can split like say date, then month, then year, day of week, monthly average, weekly average. All the stuff you can find from the numeric value of the sales. And from the date time column you can find date, month, year, week of the year, day of the week, etc., etc. And then you can use it as a you can give it the structure of a supervised algorithms suitable for the supervised algorithm. And the another approach is there. This is very unique, and this approach is known as this time sequence. So one approach in time series analysis is feature space, and another one is sequence based. Feature space means you need to develop the features from the time column, and the another column is, say for instance in this given data is sales, so from here you can develop it. And sequence based means I will discard the timestamp or the time column. I will consider only the sales or the demand column, whatever it is given in the data. Then from the column I will create a sequence. Now what does the sequence stands for? Say for at t plus 1 time, you want to predict what will be the demand. So for that, you need, let us consider, you need the demand at time t, at time t minus 1, and at time t minus 2. So you need the demand at t minus 2, t minus 1, and at time t to predict the demand at time t plus 1. Now these concepts, we are using in SARIMA. That's why I use the SARIMA. In this SARIMA, we are using. Now what we are doing, what is called this lagging. Now if you lag it in this moving average, what you are doing there is, can we express yt in terms of yt minus 1? Is there any linear expressions or linear relation? Now, even in this LSTM, you will find this, we are following this type of sequence. I just check thoroughly whether we are doing it or not. So I'm absolutely correct. That is, if you check the LSTM, so when we are predicting, say for instance, the sales focus or the stock market predictions, we need to consider almost means about 60 days predictions is required to to predict what will be the demand or what will be the price of a stock on 61st day or 61st day. Now this thing is, so I want to use this concept. So I don't want to use features-based approach. Instead of the features-based approach, I will use this XGBoost for the sequence-based. So it is a sequence-based analysis. So you got, guys, this thing is, when you are appearing in this any kind of interview, because nowadays it's the cutthroat competitions, two good developers you will find, two good data scientists they will find, and a lot of things are happening. So it is a very difficult situations. So that's why I should request my students, so when you are using any kind of machine learning approach, you should think about the simplicity, accuracy, at the same time you have to think about the computational time and how much memory it is eating. Okay, so the three different approaches. So what I did, so I use a um, I will show you. Now I will show you. Let me check whether it is shared or not. Hopefully it is shared. Yes, it is shared. Okay. Okay. So what I will do. So I tried my level best to to develop a simple approach, so that I can combine all stores or styles and all the sizes, And this thing is I will run, and at the same time I will show you the efficacy of this type of program. So it took almost 400 lines code, and hopefully it will work. Yes, it is working. See, the first one it is doing, it is basically I'm using I am using I'm showing you I'm using, yes, yes, I'm using, okay, you can check here, this beautiful graph. I'm using the sequence based approach, and in the sequence based approach I'm getting this mean square error is 1.59. So root mean square error, you can find out the square root of this one. There's the predicted value and the corresponding actual value and the strings. So it will do it. It will take almost 5 minutes time. I'm using at a simple but I should say the 4 GB laptop, so that I could see the efficacy of this algorithm and efficacy of the coding. And see, I'm getting again the mean square error for another product. It's almost 1.31. So isn't it, this is very, very faster. Okay. See, one after another it will find. Okay. So it is showing this actual value and this predicted value so that you can calculate. Now, this thing is, you can check this, how many product I'm dealing with. Say 4 stores. Just a very simple example they have given, this beautiful example, 4 stores. And each stores, we are having the 4 different styles. And for each styles, we are having different sizes. So 4 multiplied by 416, 16 multiplied by 464. So 64 different combinations we are having, so we will solve it. And at the same time, I will show you what exactly is happening here. So here you can get, see, this is a lot of folders. That is this library folders. Here you will get the code, okay? And that is this image. See, all these images you will get here, okay? And these images you will get once you will run this ARIMA, okay? This precisely it is seasonal ARIMA. And this is, here you will get the log file. This is known as the reco. I've given this name, any name you can give, it's not a big issue. So you just open it. See what I'm doing, that is I'm checking this demand planning started at this timing is given. At the same time, I'm checking this whether a particular product, I've given the product specification, is having the stock out or not. Because if your product is facing any kind of stock out, then in this case of this time series, what you have to do, you have to use some different approaches. And at the same time, I'm calculating their r square value, mean square error, mean absolute error, variance, etc. Everything I'm calculating here, so that anytime if you wish, you can go through it. So this is a simple approach, this is a simple approach. So this is, it is solving. Now, so you can check, this will solve. So I'm stopping it now. The time is very, very limited. And what I will do now, I will start the next part of the solver. So this is basically, here I will get the ordinary least square regression, OLS, and the seasonal ARIMA. So let's see. So it will take a little bit of time because I just closed and started the new one. So 2 methods I didn't touch. That is, one is this LSTM. See, okay. I hope it is cool. I hope any person will like it. And this thing is, two methods I didn't touch. One is called the there is LSTM, and another one is sequence to sequence, means this encoder decoder approach. So in this time series analysis, in my opinion, that is this, some of the beautiful approaches you can do. So if you are going to contest any competitions, or you are going to share your code to your recruiters, then you can use this extreme gradient boosting, light GBM, or the LSTM, or this sequence to sequence. Or apart from that, we have almost 68 different machine learning algorithms. You can use the decision tree, simple decision tree. You can use a random forest. You can use support vector regressions, or any other. So many different machine learning approaches are there. You can use it. So in my next video, what I will do, I will show you, almost 68 different approaches. So that you could get at least little bit expertise to compete in this job market. So just wait for a few minutes, and you will get the beautiful pictures generated by using this seasonal arima. So what I'm doing here, I got this data, and after that I'm just plotting the data, and I'm showing the distributions, because distribution is important, because blindly you cannot use this ordinary list square, as I told you, because maybe the people will not agree with you, but with my very limited knowledge, that is, if the distribution is not normal, you cannot use the ordinary least square directly. If the error terms are related with each other, then you cannot use this ordinary least square. Okay, so one thing is left here. I didn't show what is called the data transformations, because if you have the skewed data, so skewed data can be transformed. So we can convert the skewed data to approximate it at the Gaussian distribution, and we can use it for the ordinary least square regression. So that's all in brief for my students. So I shouldn't say the name of the company, please forgive me. And yeah, I got another questions. Another questions is related to this optimizations. So in this optimizations, I got the questions because I have to predict the demand. The price is given, and I have to write a mathematical expressions. These mathematical expressions where the demand and price is basically, exponentially related. So demand and price is exponentially related. It means if you increase this price gradually, the demand will drop or decrease. Now, this type of problem, you can get it, any kind of mathematical optimizations problem. Now, this is the simple approach. It is known as approximation, piecewise linear approximation. And this piecewise linear approximation means any curved line can be converted or can be considered, a collection of straight lines. That is called this piecewise linear optimizations. So you can check all these graphs you will get. So this is all about the seasonal ARIMA I am doing out now. And you can check this seasonal ARIMA, what is happening. Say it is very fast, it is showing this archaic information criteria score. And based on this AIC score, I am selecting this SARIMA order. Now SARIMA order means PQD, the order of the ARIMA. At the same time, it has the three other orders of the seasonality. Now, if the archaic information criteria is very, very low, so then it is considered that SARIMA is the best. So I hope it is clear to all of you. Yeah, I missed only one thing. That is when you are selecting, the different features, what you have to do, you have to use the Coriolis, correlations you have to check. Okay, so if the two fields are highly correlated, so in that case, you have to select it, and you have to put it in these equations. All the stuff I will discuss in my next tutorial, because this is mainly how to prepare the code and give it to your uh, company so that they could get impressed. I'm not sure of whether the employer will be impressed or not, because I'm just doing it for my students so that they could get benefited. Okay, that's all in brief. So expecting your feedback. So please share your feedback and let us know our work. I hope all of you will be benefited if you go through this video. Thank you very much.